Hey everyone! Today we're going to talk about some of the signs and symbols and Nemeth code pieces that are first introduced in the middle school grade bands. These include superscripts and subscripts, a couple of new signs like the factorial indicator, as well as complex fractions. So in upper elementary, we had learned the beginning of how to braille fractions in the Nemeth code, and by middle school, students will be getting into complex fractions. So we'll go over the code for that today as well. By middle school, students will be learning some types of mode switches. These can include superscripts and subscripts, and things that are related to superscripts that have to do with repeating things. So to write a superscript, one of those little numbers that's up above the baseline where most text is written, you might think of these as powers, like to the power of 3, to the power of 9. It includes basic things like squared. In Braille, in Nemeth code, to move up a level, to go up to the powers or up to the superscript, we use a dots 4, 5. This is used in writing things like the examples here: x squared, m to the y, and x to the power of 2 plus 4. So if I was going to write x squared, I would put my x, and then I would use dot 4, 5 to indicate that I'm going up a line, and I'd put my 2 there. That power of indicator, that dot 4, 5, is a sign of operation, and that means it also sets numeric mode through until the next space. So I won't need a numeric indicator with my 2, just like I wouldn't need a numeric indicator after a plus sign, because that raise it to the power of is itself an operation. My dot 4, 5 that raises me up a line continues until the next space, a comma followed by a space, a punctuation indicator like a dot 4, 5, 6 always ends it, or if none of those things happen, we can force it to end with a dot 5 multipurpose indicator. But in general, any kind of space will end it. If you don't have a space and you need to end it, you'll need to use a dot 5. If I was going to braille m to the power of y, I would have the m and then my dot 4, 5 and then my y. Notice that that's a 4, 5. It's over on the right-hand side like a prefix. And if I was going to have something to the power of an equation, like x to the power of 2 plus 4, I can do that because my to the power of continues to operate until one of those 4 things happens: a space, comma and a space, punctuation indicator, or a dot 5. So I can write that whole 2 plus 4 up in the power without needing to repeatedly say go up, go up, go up. Going up once will keep me there until I get to a space. To make a subscript, we use dots 5, 6. So dots 5, 6 looks like dot 4, 5, but is lower, and that tells us we're going down, right? So the top 2 dots on the right-hand side take us up. The bottom 2 dots on the right-hand side take us down. If I'm going to write x with a subscript of I, x sub I is how that's read, I would use my dot 5, 6 to indicate going down. You might also see subscripts a lot in basic chemistry equations, like oxygen exists in the environment frequently bonded as O3, that's ozone, or a simple equation like H2O. We have a simple way to write those because they're so common, and writing a number after a letter is really pretty limited to this. We would never write x2 in algebra. We'd always write 2x. We'd always put the number first. So since we don't have numbers after letters, in Nemeth, this was shortened using an assumed subscript, which is whenever a plain number follows a letter, we just assume it is a subscript. And we assume it is a number because it's written in the lower half of the cell. We know that it's a number and not a letter C. So we don't even use the numeric indicator for this. When the number follows a letter, like in O3, we just write the number after it and we assume it's a subscript. So you see that O3 would be brailled capital O and then the dots 2, 5 for 3. In H2O, same idea, capital H, dots 2, 3 for 2 without even needing a numeric indicator, and then the capital, and O. And we don't need to do anything to come back out of that subscript, because if we're using an assumed subscript, we're also assuming it only applies to one number. Might be a multi-digit number, but it's only to one number, and when that number is done, we assume we're back on baseline. That shorthand is super convenient in chemistry. It's also convenient if you have like a series x sub 1, x sub 2, x sub 3 to write like that. It makes it really efficient and really easy for that common form, but we can always use our dots 5, 6 for anything more complicated than that and be really clear that we're going into the subscript. The last thing in this kind of family of things to learn is a bar over or vinculum over the single digit. This is used in math to repeat the last digit of a repeating number. So something like 1 1/3 would be 1.33333 repeating, and they might put the little bar over the last bit to show that it's repeating. We can put a bar over the last digit by just using the bar symbol, which is dots 156. 156 is the bar symbol in any context, and when we put it right after a number, we know it means repeat this last number. Put that bar, that vinculum, right over the last number. There's another way that we'll learn kind of in high school for how to make a vinculum go longer across multiple digits, but if it stands alone without the rest of that structure, just like assuming a subscript, we assume it means just the last one digit is repeated, or just that last one digit has the vinculum over it. Remember a couple of details about those levels, those powers, the superscripts and subscripts. The superscripts and subscripts carry on until they're terminated in Nemeth. This is different than UEB Technical, where they apply to only one thing. In Nemeth, they'll keep going until they're terminated with either a space, a comma followed by a space, which actually means it terminates before the comma, a punctuation indicator like a dot 456, which occurs when these are the last thing in a sentence and then there's a regular sentence period after them. We assume the period is down on baseline. The punctuation indicator takes us back. Or when a terminator is used. The terminator is dot 5, our multi-purpose indicator. So you saw that a little bit last week. We use it again here. We'll use it for some other things in the future. You can set increasingly higher or lower indicators with multiples. So you can have a superscript of a superscript. You can have a subscript of a subscript. To do that, after you've put your first superscript, when you want to go up 2 levels, you put 2.45s. When you want to go down 2 levels, you put 2.56s next to each other. If it's the end of a sequence of Nemeth characters, like the end of a line, then we don't need any kind of terminator. In chemistry or other implied contexts, we can shortcut things like O2 by just writing the number after it. You don't need a subscript and you don't need a numeric indicator in that case. If there's a superscript and a subscript right next to each other, then follow the order in print. Do superscript first and then subscript, or subscript first and then superscript, whatever the order is. And in between them, put a terminator so that you know there's the subscript and then we're back to the baseline and then we're up to the superscript. That tells us that they're in order. If they're simultaneous, where they're stacked right on top of each other next to the letter or variable they apply to, then we do the 2 of them without terminating in between so that we know that they're stacked instead of one next to the other. In middle school, students will be likely to learn some new symbols. They'll learn the multiplication dot, the math shorthand for writing a times sign. In print, that's just a dot between numbers. It's the fastest, easiest way. And in Nemeth, it's also the fastest, easiest, dot 16, which students already will recognize as being the root of other ways to write multiplication. Students might learn signs like the percent sign, dot 4, and then the 0 shape. They might learn absolute value, which is 2 vertical lines outside of a number. For example, here I have the absolute value of -3, which would solve as 3. Absolute value is the same as an OU shape. and it's considered a grouping indicator in Nemeth. Students might learn Factorial, which in print is an exclamation mark written after a number. In Braille, it's the and symbol, 1, 2, 3, 4, 6. And factorials mean to multiply the number by every whole number smaller than it down to 1. So 5 factorial would be 5 times 4 times 3 times 2 times 1. In these grades, students may also learn comparisons such as ratios and proportions. These are signs of comparison, and so they are built on the right-hand prefix of the cell and then a left-hand root, just like the equal sign is with its 4, 6, 1, 3. Ratio is .5.2, and proportion is .56.23. So they're all two cells, and they're the adjacent sides of the cell. In middle school, there's often a resurgence of a strong emphasis on labeling your units. This is often when kids will learn the history of NASA missing the mark because miles and meters were confused. Important to label your units. In Nemeth, units are always spaced from the number they apply to. Single letter units do require a grade 1 indicator, but multiple letter units do not, as long as they can't be confused with short forms. I have a few examples for you here. The first says 15 miles. The second says 3 centimeters plus 2 centimeters. Notice that centimeters is always spaced from the number it applies to, but the plus 2 is not spaced from centimeters because plus signs are unspaced from the things adjacent to them. That means that the plus is unspaced from the whole unit, 3 centimeters, and it's unspaced from the whole unit, 2 centimeters, even though that unit has a space within it. Because the 2 is unspaced from the plus sign, it does not require another numeric indicator. But the 3 did because it started the line or followed a space. The last example says 5K, like a person might run a 5K. In print, the K of 5K is traditionally written unspaced, but in Nemeth, we always space units from their numbers, so there we would space it and put a grade 1 indicator or an English letter indicator because it is a single letter unit. By middle school, students already know how to write fractions. They're familiar with the fraction opener starting numeric mode and needing to close any fraction they open. In middle school, students will add on complex fractions, which are fractions with another fraction in the numerator or in the denominator. The sort of full and complex form of that in Nemeth ends up being a big fraction opener, followed by the fraction opener for whatever fraction's in the numerator, its numerator, the fraction line, its denominator, and a fraction close. Then the big fraction's big line, a fraction opener if there's another fraction in the denominator, that one's numerator, its fraction line, its denominator, that little fraction close, and then a big fraction close. And you can see an example of that even includes a mixed number. If you look in the row that's got the big and complex fraction in it, you'll note that there is color coding for what each fraction applies to. So in that version, you can see the 1/3 that's in the numerator written here in red. You can see that the big fraction line is in blue, and so all of the pieces of the big fraction are in blue, including the big fraction opener, the big fraction line in the middle, and the whole number 6 that's part of the big fraction's denominator. And then at the very end, the big fraction close that follows everything that was in the big fraction's denominator. You can see sort of the order of nesting clearly that way, and an example of all of the bits and pieces. So certainly take a look at that handout if you find that style of breakdown helpful to you in understanding how to nest your fractions. Those are all of the concepts for new symbols and new ways of writing things that are generally in middle school math. That handout, of course, also has radicals on it, so if your students are doing square roots, it's included there as well. Until next time, happy brailing!